Hello my dear students of class 11. Today we will be starting with a new chapter, that is chapter number 13, hydrocarbons. So hydrocarbons is classified into three categories, that are alkanes, alkenes and alkynes. So here we are going to learn about alkenes first. So we are going to discuss about methods of preparation of alkenes. So methods of preparation of alkenes. The first one is by decarboxylation of carboxylic acids. So D means here removal, okay, and the carboxylation means removal of carbon dioxide. So this decarboxylation of carboxylic acids is the first method of preparation of alkene. And please remember, the general formula of alkene is CN H2N plus 2. Okay, so this is the sodium salt of carboxylic acid, and this is the sodium salt of carboxylic acid. Whenever sodium salt of carboxylic acid is treated with soda lime, that is NaOH and calcium oxide, okay, sodium hydroxide and calcium oxide, sodium hydroxide and calcium oxide, and heat it, then what we get is we get alkane and sodium carbonate. So here R is alkyl group. Now it could have many carbon chain, and here we have an example where this R is equivalent to CH3 alkyl group. Now whenever this R is replaced with CH3, then it is known as what? This is sodium acetate. It's the common name, and its IUPAC name is sodium ethanoate. So sodium ethanoate, whenever it is treated with soda lime, that is NaOH and calcium oxide, and heat it, we get methane and sodium carbonate. Now how do we arrive at the product? Now here you can see it, that this COONA and this NaO, they combine to form sodium carbonate. Here sodium carbonate, you can see it, 2 sodium atoms, 1 carbon and 3 oxygen, so that will result into sodium carbonate, and this remaining hydrogen of NaOH will get bonded with this carbon, and here now it will be having 4 hydrogen, that is CH4. Okay, so this is the first method of preparation of alkenes. The second is Colway's electrolytic reaction. So here it is, the alkenes are obtained by electrolysis. Now here aqueous solution of sodium acetate is taken. Now aqueous solution of sodium acetate, when electrolysis is carried out, what will happen? They will separate into cation and anion. This is sodium plus, this is a cation, and here CH3 COO minus will be separated out as what? Ions. Now as we have learned in electrolysis, that cations will be going to the cathode and anions will be going to the anode. Here you can see that at anode, since I told you this is the aqueous solution of what? Sodium acetate, here water is also present. Now this water and sodium, both of them will be going to the cathode, and they will, at cathode, what they do, they gain electron and they get converted into sodium atom, OH minus ion and hydrogen. Similarly, this is the anion part, that is the negative ion. Now this negative ion is anion and it will be going to the anode. Okay, so at anode, what they do is they lose electron, and here you have to see that here it is there is a dot over oxygen. This dot is radical. Okay, so 2 of these radicals, like here 2 radicals of this acetate radical will combine among themselves to form ethane and carbon dioxide. So here the bond between this carbon and this carbon, it breaks. Okay, so you have 2 molecules, so here in each molecule this bond breaks, and what will happen? So let me write one more CH3 molecule over here, CH3 and COO radical. Okay, now this bond also breaks here. Now there is combination of this CH3 group and this CH3 group, and these two COO and this COO, they combine to form two molecules of carbon dioxide, and these two CH3 and CH3, they combine to form C2H6. You can count the number of carbon and hydrogen here. Okay, this is how we obtain ethane in particular or alkane from Colway's electrolytic reaction. So you have to remember electrolysis is carried out in this process. The third one is very simple. The third one is from alcohols and aldehydes. So here what is important is you have to remember the catalyst. Okay, the catalyst and the reason that are used. Now from alcohol, if you want to prepare alkane, that is RH, then it has to be treated with red phosphorus and two molecules of HI. So whenever alcohols, this is alcohol, is treated with red phosphorus and two molecules of HI, it will give alkene as the main product, and the byproducts are water and iodine. Similarly, now the next important part is Wurtz reaction. So Wurtz reaction is very simple, and this method of preparation of alkane is from alkyl halide. So alkyl halide, RH is the general representation of alkyl halide, R is alkyl group and X is halogen. So here we are going to take two molecules of alkyl halide. You can see that one molecule is here, RH, and the other one molecule is here, RH. So two molecules of alkyl halide, whenever it is treated with sodium atom, and how many of them is required? 2 atoms. So whenever alkyl halide is treated with sodium atom, then what happens is this X of each alkyl part gets bonded with this sodium, and now this R is left here and this R is left here. Now this R and this R, they combine between them to give you RR. That means this is now alkene. Okay, this is alkene, and the byproduct is NaX. So you are having two molecules of NaX. So this reaction is known as Wurtz reaction. Please remember. Now next topic that we have is from Grignard's reagent. So from Grignard's reagent also we can prepare alkane. So this is our alkane. You know the formula for Grignard's reagent? The formula for Grignard's reagent is RMgX. So whenever RMgX, that is Grignard's reagent, is hydrolyzed, we obtain alkane. So how the reaction takes place? The valency of magnesium is 2, so it is bonded to R and X respectively. Now this water molecule, we can write HOH. Now this H of water molecule combines with R. Okay, R is alkyl group. Now when alkyl group is bonded with this hydrogen, then we get RH, and this is now our alkane. This is our alkane. Okay, this is our alkane, and to fulfill the valency of this magnesium, this OH now gets bonded with magnesium, and as a result we have Mg, OH and X. So these were 5 general methods of preparation of alkane. Now let's move on to the next topic, that is chemical properties of alkane. Okay, so the first one is oxidation. So under oxidation, the first one is combustion. So as I told you, any hydrocarbon, whenever it is burnt in oxygen, they will always form water, and if oxygen is in excess, it will give you carbon dioxide. Please remember, whenever you have excess supply of or sufficient supply of oxygen, then they will always give you carbon dioxide. Now whenever same methane is treated with oxygen, and in this case this point is very important, limited, whenever there is limited supply of oxygen, then instead of getting carbon dioxide we get what? Carbon monoxide and water. Likewise, if you have even insufficient supply of oxygen, then instead of getting carbon dioxide or carbon monoxide, we get only carbon. The water is present in all the three cases. Just you have to remember that whenever there is excess supply of oxygen, we get carbon dioxide. Whenever there is limited supply, we get carbon monoxide. When the supply of oxygen is too limited, we get only carbon. Okay, now let's move on to catalytic or controlled oxidation. So whenever methane is treated with oxygen under different catalytic condition, we obtain different product. So this catalytic or controlled oxidation, what do we mean, or what do we understand? We understand that by using different catalyst, we will be arriving at different products. So here are some of the points that are very important. Okay, so methane, whenever it is treated with oxygen and in presence of copper tube, please you have to remember this, in presence of copper tube and 120 atmosphere and 475 Kelvin, we get alcohol. Please remember, see, OH is present. So in presence of copper tube and at this atmospheric pressure and this temperature, we arrive at what? Alcohol. Similarly, when instead of using this condition, this set of condition, we use molybdenum oxide. See, you can see here the reactants are same, but what is different? Here the difference is in the use of catalyst. Here we have molybdenum oxide. Now in presence of molybdenum oxide, methane reacts with oxygen to give you aldehyde, and here in particular this is formaldehyde. This is what? This is formaldehyde. You are getting what? Aldehyde. Here you got alcohol in presence of copper tube and this condition, this set of condition. But the same reactants in presence of molybdenum oxide, we arrive at what? Aldehyde. You have to remember these two equations carefully. Now whenever you have a long chain aliphatic, this alkenes, now whenever it is treated with oxygen and the temperature condition is 373 to 433 Kelvin, then we get what? This is carboxylic acid. So what we have here, this is our carboxylic acid. Carboxylic acid. This is our aldehyde and this is our alcohol. So under different catalytic conditions, we get different products from alkenes, and in particular here we had taken methane into cases. Now let's discuss about more chemical properties. So the next property that we are going to discuss is substitution reaction with chlorine. So substitution, you know, now these hydrogens of methane will be substituted with chlorine. So here you can see how many hydrogens are present, 4 hydrogens. Now all these 4 hydrogens are substituted with chlorine. Okay, substituted with chlorine, and this hydrogen reacts with 1 chlorine here and it will give you HCl. So while balancing the equation, you have to see how many hydrogens are present and how many chlorines are present. Now this reaction takes place only in the presence of what? Sunlight. This reaction takes place only in presence of sunlight. If sunlight is not present, then this reaction doesn't take place. Now the next reaction that we have is, this is another chemical properties of alkane, pyrolysis. So what is pyrolysis? Pyrolysis is breaking down of what? The alkane chain. So here you can see that this is alkene. When alkene is heated at high temperature, now the bond between this carbon has broken. So here you can see that we have got alkene and methane. Here how many carbons were present in single chain? 1 2 3, but here you can see that 1 2. So whenever there is fragmentation of an alkene chain into smaller one at high temperature, then that is known as what? Pyrolysis. The next chemical property is isomerization. What is isomerization? Isomerization is they will be having same molecular formula excuse me, they will be having the same molecular formula, but their structure will be different. So an alkene, you can see that here you have an alkene, this is an alkene. This an alkene, on heating in presence of aluminum chloride and HCl, it has converted to branched chain. So you can count the number of carbons and hydrogens before the reaction, and after the reaction they are what? They are same. But it is that here before the reaction it was present as a straight chain, but after the reaction it has turned into a branched compound. Now this takes place only in presence of aluminum trichloride and HCl, and whenever it is heated. Such a reaction is known as what? Isomerization. Now the last chemical reaction, chemical property that is there in your syllabus is aromatization. So what is aromatization? Whenever this N alkene having 6 or more carbons on heating at high temperature, and you can see temperature here is what? 773 Kelvin, and at 10 to 20 atmosphere, now they get dehydrated and they turn now into a cyclic form. And this cyclic form, and here you can know the structure here we get is what? Benzene. This is what? This is benzene, and you know benzene is an aromatic compound. So you can see this 1 2 3 6 1 2 3 4 5 6 carbons are present, and it is present in a chain. It's a chain, it's not in ring form, but after the reaction it has turned into a ring form. And moreover, please don't forget, you have double bond, 3 double bonds which are present alternative, single bonds and double bonds are present at alternative position. Now this compound is what? Benzene. The most important part here is the presence of catalyst. Okay, in presence of chromium oxide or vanadium pentaoxide, you have to remember this. Now if you just take this an alkene, and you haven't put any catalyst, and you have just maintained this condition, you have heated at very high temperature and maintaining this atmospheric pressure, you will not be arriving at this product. The presence of this catalyst is must. So aromatization, what does it mean? In simple words, it means an alkene will be converting into ring form. Moreover, that ring compound will be aromatic, like here it is benzene.